in our last video, we used two different examples of the same elasticity formula. And so I wanted to make a video explaining how these are actually the exact same formula. Because they might look very different. You might think, okay, that's cool, you have one formula that equals one thing and one formula equals another thing, but they're actually the exact same formula that are kind of interchangeable. And so let's break that down. We'll use this formula over here on the left to get to this formula here on the right. So let's rewrite this formula. Let's write it as E equals force over area. But let's separate our two fractions we have, or proportions we have, of original length divided by our change in length. And so as you can see, this is the exact same equation right here between these two. I just separated out our little proportions, our little fractions. And we also know that stress equals force over area. When it equals something, that means you can basically substitute it. So we can rewrite this equation. Now we can say elasticity equals stress. And where do we get stress from? Well, it's right here. This force over area is stress, times the fraction length original divided by our change in length. So as you can see, we're kind of already halfway there. And you might say, well, Mr. Anderson, I know that epsilon is change in length over length original. How do we get this? How do we get this to flip? How is this upside down? And the answer is really simple. Well, what we do is we take epsilon and we set it equal to epsilon over 1, which is the exact same thing. And I'll set that equal to our change in length divided by length original. And if this is true, then that means our inverse epsilon, epsilon to the negative 1, is equal to the inverse, which is 1 divided by epsilon. And if we flipped this fraction, if we flipped epsilon over 1 to 1 over epsilon, well, then we flipped what it's equal to. We flipped, instead of length original being on bottom, length original is on top, and that means the change in length delta is on bottom. And now we're cooking with fire, because if this is equal to this, then that means we can replace it. So we can rewrite this equation as elasticity equals, well, it's stress, we found out earlier, times 1 over epsilon. And we can rewrite that to say, well, elasticity equals, well, it's stress times 1 over epsilon. And well, we know stress times 1 is just stress, so that cancels out. And what we're left with is elasticity equals stress over epsilon, which is our strain. So that's how we get the formula. Elasticity is stress over strain. And so hopefully you can see how these two equations are interchangeable.